This final video introducing our different sort of types of probability is going to focus on a type of probability that in math books is referred to as conditional probability, but I like to call it subgroup probability because I find that if you think about this as I'm just looking for what is the likelihood that someone in a certain smaller subset of the bigger population fits certain characteristics, makes this easier to think about. I will warn you in advance that if you Google conditional probability, you will get some crazy, scary looking formulas. And so we're going to try and simplify this as much as possible for you. All right, so subgroup probability, the probability that A occurs given that B already happened. That's the sort of rule. And notation-wise, you'll see it sometimes as probability of A given B. And also we'll make this sort of notation of A, and then there's this line between them, and then B. And that's just saying A, and you could think of that line as it represents given B. So the point is it's like the probability that A will occur given that B already has occurred. So the thing to keep in mind in this is B is the subgroup. So it's like I'm now only focused on people that have characteristic B. They have to be within group B. How many of them are also in group A is another way to think about it. So that's what I was sort of saying here. Knowing that the person is in group B, so we're already focused on group B, what's the chances that they are also in group A? So how I then think about this is what's happened is our total is now different. Our total is no longer the entire group of people. It's going to be the number of people in group B. So it's like the number of times B occurs is often how we word it. So the number times B occurs. Okay. And that's now my subgroup. So you could also think about it, the number in group B would be another way to think about it. So that's now my denominator. The numerator then is basically the overlap between A and B. It's who's in both A and B. So it's the number in both A and B. So it's your overlap between the two groups is a good way to think about it. And that's sort of what we're looking for. So notice we now have a subgroup here. So our denominator has changed. And we're saying within that subgroup, how many people also share characteristic A. I'd say the hardest part with the conditional probability is interpreting the question to figure out the subgroup. So you want to look for words like given or knowing that a person fits in this group or some sort of language like that. So I'm going to give you a potential one. So we have probability daily given Gen Zer. So what you might see here is like, what's the probability that a Gen Zer is also someone who gets news daily from social media. So notice my question doesn't actually have the word given in it, which throws off students because sometimes they're like, I just wanted the given. Can I just find the given? I found the keyword and can I move on? So I have to really think about it. So yes, the given Gen Zer is my subgroup, but it's here, what is the probability that a Gen Zer? So I'm already saying like the person is a Gen Zer. So that means I'm not looking at my entire table anymore. I'm only focused on this top subgroup. I can ignore everything else on this table. I'm just going to cross it all off. I'm ignoring it all. It no longer matters, which means this is now my total. My total is 531. That's my subgroup. Subgroup. Now, within that subgroup, how many people got their news daily from social media? And so that's the people within my Gen Zers who are also the daily watchers. Well, that's just that overlap there, the 267. And that's my probability. So these are both daily and Gen Zers. So they have the number on the top has to be in the subgroup. And notice the wording on a problem didn't give away what the given was. It was, I tried to make it a little more complicated, but just to give you a sense, it implied, okay, what's the probability, a person who's a Gen Zer, I'm no longer saying what's the probability that a person, it's what's the probability a Gen Zer. I'm only focused on that Gen Z group. All right, and then just like all my other probabilities, we want to just practice turning that into a percent. So we would divide those numbers. I would come out with the decimal 0.503, which would be about 50.3%. So, all right. Now, if we flip that around, so just, talking about notation, if I were to draw this with the little line, it would be probability Gen Zer with the line daily. That's what it would look like. So I could say, if I were to write this in words, just, I like to show you the different ways. What's the probability a Gen Zer, sorry, what's the probability someone, to word it correctly, I can't do it off the top of my head, sorry, what's the probability someone, I got it, what's the probability given someone watches, or not watches, I want it to be watches, someone gets news daily from, what's the probability given someone gets news daily from social media that they are also in Gen Z? So the given is that someone is a daily news watcher or gets their news daily from social media. What is the probability that they're also in Gen Z? So we've flipped around our subgroup. This time our subgroup is that daily because we got the given, the daily. And so now I need to erase my whole table. I have a different total. Oops. My daily is what I care about now. And I could cross off the rest of this. I don't care about the rest of this table. And so now, oops, I went a little too far there. Now my total is this 1,579. And of that, how many are in Gen Z? That overlap, the 267. So our subgroup now is daily. And so we pull that total from the daily group. But you'll notice that the numerator is actually the same as the other one, because remember that this is still the daily Gen Z number. And this comes out to a decimal 0.169, so that's about 16.9%. So if I'm just looking at those daily, the people who go to social media daily for their news, the chances that that person is also in Gen Z is pretty low. So hopefully this gives you a sense of what to look for with our subgroup probability. The key is really, the first question should always be determining what is the subgroup. And it is one of those ones where you need to read the problem really carefully and make sure you're interpreting it correctly. And it might be one where you might want to stop and ask a friend if they're interpreting it the same way, because this is one where the words matter. And if you couldn't tell from me just trying to write the questions, it can be sometimes challenging to interpret it correctly.